Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about solar cells. So let's dive right into it. Now first, what exactly we are talking about? We are talking on a very fundamental level, something that turns photon into electron movement. So what does that translate to? Turns light into electricity basically. And one core aspect of the system is that you can technically do light into electricity hundreds of ways, but this puppy can do that in solid state. That is very critical and very important for this thing. There is no moving part in this. You can have basically run a motor out of this without any issue. Everything is solid state on a fundamental level. So that's amazing. Another aspect, it creates direct current. Now that may be desirable, that may not be desirable. For my solar watch, that's a desirable aspect. For power grid, that's not a desirable effect, but it can be managed. We have good enough inverter technology at this point in time. So this is what we are talking about. Let's understand this magical aspect of how the heck a solid state device can like basically receive light, have no physical changes, and yet somehow create potential difference for us to extract electricity out of it. How the heck that happens? Well, we come to semiconductor technology, aka silicon baby, and we start with p-n type technology. Now what does that translate to? That simply translates to you have one layer of semiconductor that is quote unquote doped with fancy stuff. Now that fancy stuff creates a scenario where it has surplus electrons. Basically it has more electrons. It's kind of like a charge kind of scenario. Then you create another layer which has same silicon but doped with something else, and at that point in time it will have what we call electron hole. So it is in kind of negative state. Now this is fundamental basic level stuff. This is how your every semiconductor works. You have p and n junctions, how they are mixed, how are they mixed matched, how they are layered together. That's how you get different kind of junction IGBTs and all that jazz. Basically this is fundamental level how semiconductor technology works. So this is just a power harnessing variety of that. Now interesting thing happens when you have two of these junctions, basically n type and p type, touching each other. Basically you touch them like this. Now because there is a layer which has surplus electron, there is another layer which has less electron. What happens? They equalize each other. That equalization zone, that zone basically where you have this n touching the p type, you have this zone that becomes stable depletion region. Now what does that translate to? That translates to everything is chill here, everything is like calm, everything is relaxed. Now what does that translate to? That translates, this is a fertile ground. So if a high energy photon, now high energy simply means as in like anything that has enough energy to push the electron away, and that depends on different crystals, different elements. Every element have a different kind of quote unquote breaking energy. Basically you have to dump this much energy for electron to leave it. Now this requires like an infrared kind of thing. So don't expect this puppy to convert radio waves. It requires a photon of at least that level, like at least infrared. Thankfully our sun is very bright in infrared. So infrared reaches this point and knocks electron off. Now here's the deal. Once you create a what we call n and p junction, you created a diode. Even if electrons are created, even if electron holes are created, they cannot combine back up because it's a diode. They are inside a diode. They have only one way to go. So basically electrons goes to the top, it creates a negative potential there, and electron holes go to the p side section where it creates a backing, basically positive and negative you end up with. So what does that mean? How do you equalize that? You short circuit it. Basically you run the electron through a load, and that's how you get electricity out of it. So let me be very clear, there's nothing fancy going on. It's just have one layer that has too much electron, another layer which has too much electron hole, and the meeting point, they equalize inherently, but they still have a potential difference on the top layers. One is negatively charged, another is negative hole charged, quote unquote positive. And because photons are dumping energy inherently, and because there is a diode architecture here, it cannot go backwards. The electron, even if it's released in the same layer, it cannot just go to p side, it has to go to n side. So that creates a loop of electrons that we can do. And because this is happening inside a complete loop, there is no thing that is being consumed. It's not like a chemical cell where you are consuming something else. So fundamentally this puppy can run for very long time. And in modern times of time, this is the only device that you can reliably count on working after 20 years. These puppy have warranties sometime as long as 25 years, and company have enough track record to no, this cell actually does work after 25 years. So you can understand these are serious technology. That's how it can achieve solid state electricity conversion. It's just a diode which has quote unquote let photons reach into the air, active basically calm area. It becomes active area dumps electron, and electron holes becomes unstable. It creates a potential difference, and then the moment you put a load to it, electron flows. You get the whole system out of this. Now, be mindful in real life. The basically N and P junctions, they are completely different. These are how they are doping it, what mixture they are using, what kind of thickness. These are trade secrets. For example, rough A generally, because you want light to reach the border region, the N section is generally made very thin. If you make something thin enough, it becomes transparent enough by default. So 2 micron would be the thickness of N side, and the P side could be as thick as 300 micron. That is the most optimum we have found through trial and error and some very complicated mathematics. So that's the whole point of it. You light reaches it, excites it. Because of the architecture, electron cannot flow backwards, and that's the critical aspect. Photons, when it hits something, it generally will impart momentum on electrons. Problem is, electron has to flow in one direction, otherwise it's no use, otherwise it's just heating up. So that's why we need that silicon technology. And again, depending on different kind of elements that you're using, you will have different quote unquote band gaps, different kind of energy requirements. So some cells would be very optimized for blue light, some cells will be optimized for infrared. So be mindful of that. And that's why we are so lucky. Basically, our sun is kind of bright in infrared, and silicon is very good at that kind of spectrum. So red to infrared zone, these cells are like, we got this is our perfect zone, perfect photon energy level. This works. Now if our sun was kind of bright and it was illuminating in x-rays and gamma rays, this is like useless. It's like photons will simply go through, will not do anything, it will just whoosh. So we are surprisingly lucky in that regard. Now let's understand this one aspect. The moment you tell someone is like, I want to do this to save planet, nobody's gonna give it up. The moment you tell someone, hey, I'm gonna do this and it's gonna make you rich, every Tom, Dick and Harry is gonna do that. Solar, ironically, has finally made it into a point where it can actually do that. It's like, I'm gonna save you money and I'm gonna make the planet better also. Enjoy. So solar have done that, and it is slowly coming to real world. What does that translate to? That translates to, if you move around, you will find a solar farm near you. I can guarantee that. Heck, I'm saying that in India. It's like I can literally go on a ride, and before 1000 kilometers out, I will found a solar farm. And there are many solar farms near me. It's like some are small, some are big, some are huge, but you get the point. Like there is more than enough at this point in time that common public average person can see that. And if you're living in a place where electricity cost is ludicrously high, be it Germany, be it Australia, people will have rooftop solar farms. Because you have to understand this, at this point in time, solar has finally touched, or some cases broke through the coal pricing, because coal is the fundamental energy provider in almost every sector. Only some countries in some unique scenarios are running on natural gas, but almost everybody else is running either a hydro or running on coal. In India, we do have some hydro plants, but none of them are like super huge or very big. So even our backbone is coal based. However, if you can beat coal pricing, every Tom, Dick, Henry will do it, and simply because it's efficient. Everybody cares about their pocket, and you're gonna say, hey, we're gonna make this farm, and maintenance cost is almost negligible. The transport and taxing and all that is almost negligible. There is barely any moving parts, some spare parts, and some cleaning staff. They're like, shut up and take my money. And that is happening. That's the very interesting aspect of it. It makes sense for homes, specifically in a metropolitan area, because if you have a home in metropolitan area, your electric bill could be ludicrously high. In those sort of places, people are like, dude, I can't afford to pay electrical bill. It's cheaper to just pay equivalent of a car near you. You can pay that amount of money to get solar farm. It's like, okay, finally I'm free from electrical bill. That's ludicrously expensive. Per kilowatt hour is ludicrously expensive. So it's already making sense, and it's making sense in India also. So lot of things are happening, and consequence of that, we are going bigger. Like India has slowly went from commissioning 1 megawatt solar farm here, 2 megawatt solar farm here, to 20 megawatt, to 200 megawatt, to 20,000 megawatt solar farm that is being commissioned at this point in time. So be mindful, it has reached economical viability. It's one of the few things that can truly say that that it has reached economical viability. So everybody wins. It's like we have less carbon emissions, we have less pollutants, and everybody gets to enjoy electricity. So everything is awesome in this regard. And this also has long life. So it's not like, okay, we do it and every 5 years. No, this puppy lasts almost same lifespan as a freaking coal power plant. Like again, coal power plant will not go down after 20 years. They have to do maintenance on the turbines at that point in time. So surprisingly awesome. Now there are certain limits. While it is amazing, while it is running cost competitive, the sole reason it has not taken over everything is has to do with two core factors. Factor number one, which is really annoying for Indians, is like, it does not like higher temperature than 25 degrees Celsius. I'm like, what the heck? Like even Indian manufacturer like Luminous, you read their spec sheet from the solar panel, it's like at this kind of radiation, we got the radiation. Like solar radiation, like we got this, more than enough. Cell temperature should be 25 degrees Celsius, then the rating is qualified. I'm like, dude, If you are putting that kind of radiation on a cell, it will not remain at 25 degrees Celsius. Like if there is no wind blowing on top of it, cooling it regularly. But again, it's a known kind of issue. But if we can design cells that work this kind of efficiency, nothing magical, just this, but at higher temperature, as in let's say 53 degrees Celsius or 60 degrees Celsius, we good, we're solid. Because most places we can't put solar panels, simply they will be overheat and they will not produce desired power. Like India has a lot of railways, and those railways have very large tops that can provide lots of power, like more than enough power to run, like especially some trains have like only 2 or 3 coaches with air conditioning. Those can be directly running off of that, directly, super easy, efficient, actually saving energy and all that. Just we don't do that, simply solar will cook itself. So you have to understand that aspect, that 25 degrees Celsius is a very lame. Now again, be mindful, some cells are much more durable. So even at basically higher temperatures, in like as high as 50 degrees Celsius, instead of going down from let's say 335 watts of power, it will go down to only 300 watts. But the panels that can do that, they are very expensive. Another aspect is why it gets hot over time. If it's converting energy, it should not get hot, it's simply absorbing energy. So why the heck it's getting hot? It's because efficiency is not that high. Now real world efficiency, real world as in like you buy this, you put this in your rooftop or your solar farm, how much you are actually gonna get, your best case scenario is 20%. Now be mindful, cells do specify, there are cells that are like 23% efficient, some expensive LG and Panasonic cells, but they rarely do that in real world. In lab condition, awesome. Real world, hell no. So 20% is like best case scenario. Now there are systems that do achieve higher than that, some even high as bonkers 40%. And we do utilize those kind of technology in something like International Space Station. Now I don't have to specify that these puppy is ludicrously expensive, and that's the problem with this. The sole reason we utilize semiconductor technology and silicon specifically is we know how to mass produce it. You have to understand this aspect very thoroughly. Almost everything works in a lab. The moment you reach mass production, 99.999% of things go poof. That's the whole reality of it. And silicon did not went poof. We know how to mass produce it. That's why we are utilizing these cells. They had to be custom built for ISS. There are manufacturers that build that. Like you're just gonna ask them, hey, can you make the cells for like let's say 2000 megawatt solar farm, which India have. India have 2000 megawatt solar farm. Then like yeah, it's gonna take us like freaking 8-9 years to commission you all that. So reality is we cannot mass produce it. That's why these high efficiency cells are only limited to space industry or again research purposes. And if you really have deep pockets, you can afford this. Again, be mindful, at those kind of prices, Ferrari will start to look cheap. So what we can expect in the future? Now this is one thing you have to understand. Solar is reaching to common people. It's something that is not like, oh, it's happening offshores. It's not happening like, latest and greatest kind of research development. No, it's reaching common people. Heck, my solar watch, I have solar watch. So reality is it's touching common lives. That's a very good thing. Like that's a green technology that's like people are using. People in Australia, people in Germany, people in India. It's like, especially I have seen a lot of YouTubers who are like doing interviews with couples living in Bangalore. It's like, dude, my house electric bill was so damn high that like buying solar was like, I have to do it. It was not like it's a good add-on. No, I have to do this because it's financially more responsible. Because solar farm systems, even with inverter being the weak link, inverter supposed to last 10 years, and if you get the solar farm, you should have return on investment as early as 3 to 4 years. That's like, you have to do this. It's not optional, you have to do this. So be mindful, it's reaching what we call maturity and viability. Both are amazing for this. I cannot just tell you, hey, even if you are living in a windy place, I cannot just say go to this company and this company will sell you a vertical access wind farm. There is no standard for it, there is no known system. There is like, I cannot just go from this manufacturer or go this installer. There is no technology that is at this level of maturity. Another aspect, it can provide more than enough power. And I'm not talking about like covering every single patch of land. I'm talking about if you cover every single rooftop that can be covered in this. I'm not talking skyscrapers, I'm talking schools, I'm talking airports, I'm talking basically hospital buildings, I'm talking about like small family households. All those things, you will have more than enough power. Like fundamentally, this green technology is one of the few technology that can truly say, I got this. It's like you just have to spread it. And currently, given the fact that it's already become almost as cheap as coal, people are already doing it. That's why it's so amazing that if you can do this, like if you really get the ball rolling and actually start to cover let's say parking lots, airports, basically every place where you can cover it, where you already have paid for the land, we're taking care of it. It's like, we got this, relax, we're just like taking care of this situation. And let's say after a lot of research, because technically we should be able to reach 30% efficiency on single material system, which may allow it to be mass produced as early as 2025 or 2026. If we are ludicrously lucky, I will not bet on it, but maybe. And if that actually happens, that's something that by the cell, and it's actually 30% efficient in real world use, not just lab use, real world use. That's a dramatic energy savings, energy saving, I'm saying energy production. What does that mean? That simply means A, your cell will remain cool because A, it's more efficient, and B, same amount of panel will produce more amount of wattage. That means every solar farm that was, let's say you bought the land, you got the solar panel, they worked for 20 years perfectly, and you're like, okay, now I should replace them. You will replace with that is more efficient. Let's say instead of 18% efficiency, you're getting let's say 25% efficient or 29% efficient. You're like, dude, you will double your profits. So even minor gains, it's like little bit more, is going to translate to a lot of money. That's why people are pouring their money like there is no tomorrow. That's why LG, Panasonic, every company that can do research on this, they are doing it simply because it's financially viable. That's amazing. It's not like, okay, government have to give incentive or government have to burn through billions of dollars for this fusion technology. No, it's like, do it. Like people are doing it. It's like the same reason iPhones are self-funded, the same reason Tesla is self-funded, same reason Android is self-funded. It's like, it's profitable. Solar has reached that point. That is amazing. And in terms of how about the next level, like we got the solar cell, it's matured, it's mass produced. What's the next big thing? Next big thing is multi-junction system. Basically you will have multiple diode architecture, and again two flow back diodes to make sure what we call tunnel junction, so electron does not flow backwards, and each layer, quote unquote, each junction will be fine-tuned for one spectrum, so to say. So you can take a scenario where like ultraviolet, I'm saying infrared to red will be taken care of one junction. Then you have yellow spectrum that will be taken care by one another junction, green spectrum another junction, blue spectrum another junction. And this puppy in theory, in principle, can achieve as high as 60% efficiency. Now that's ultra bonkers. That's so goddamn high that it will triple the power output of every solar farm. That's GG. That's like at that point in time, even skyscrapers could literally, like, if they don't have window there, they will have solar panel there, because it will that make that kind of energy. So solar is very serious. It's here to stay, and it's actually making financial viability. It's actually reducing our carbon footprint as we speak. So it's not some far flung out. So there is a lot of money, lot of investment, and a lot of potential into this technology. So I'm looking forward to this. Heck, who knows, maybe 4 or 5 years from now I might have to put solar farm on my roof also. So this was my presentation about solar cells. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.